Hey geometry team, it's Mrs. Cerna. Welcome to Unit 8, Day 2, and we are going to be talking about what's called inscribed angles in a triangle. You're very excited. So let's go ahead and look at one really quick. So an inscribed angle, if you want to look here, ooh look, fancy toys. So you talked about central angles, where the angle is at the center of the circle. So you've got this lovely little angle here, and its vertex is right at the center. In an inscribed angle, we're going to take that vertex and we're going to move it to some point on the circle itself. So this would be an inscribed angle. This would be an inscribed angle. This way over here. I could take it way off here. This is technically a very small inscribed angle. Okay, so we have these inscribed angles. Now if you think back on our central angles from the previous lesson, central angles, their measure right here was the same number of degrees as the arc it intercepted. So whatever your arc measure was, your angle measure was, and vice versa. Whatever your angle measure was, your arc measure was. Well, with inscribed angles, watch what happens. This arc is going to stay exactly the same. But as I move the vertex out to the edge of the circle, this angle here got smaller. Look right here. Right here, it's like 45, 50 degrees, something like that. It's a pretty good size angle. But as I get here, it is getting stretched and getting skinnier and skinnier as it comes out to the edge. Good job, Mrs. Cerna. Let's come back. Okay? And so the measure of this angle is not the same size as it was when the vertex was on the center. And in fact, the measure of this inscribed angle is always going to be half whatever this arc is. So if we were in here and had this central angle, and let's say that this is 60 degrees. Why not? So I've got a 60 degree arc and a 60 degree central angle. If I take it out and make an inscribed angle instead, I've still got a 60 degree arc. But now this angle over here is only going to be 30 degrees because it's half as big. It had to go twice as far. So it's half as big. Now if I take it down here, guess what? This is still half as big. This is still 60, so this is still 30. Any inscribed angle that I choose to take from this particular arc is always going to be half of that arc that we inscribed. So, knowing that then, let's talk about it. We had our central angles that we had already talked about previously. And we said that the measure of the angle equaled the measure of the arc. I already handled that. Our inscribed angles now, whatever the measure of the arc is going to be twice as big as the angle, and the angle is going to be half as big as the arc. Okay? So the measure of the angle is half the arc, and the arc is twice the angle. So here I've got the angle as 20. And so this arc right here, well, if 20 degrees is half of my arc, this arc had to be 40. On this one, my angle is 140, and so it's half of my arc. And so the arc up here, let me get a better marker. Oh yeah, now you can see some nice bright orange there. No, maybe not. But either way, this is going to be twice that, so it'll be 280 degrees. And then on this last one, my angle is 10. It's half my arc, and so my arc had better be 20 degrees. Okay? Now down here, we've got some other stuff going on. You don't get to learn about this. It's top secret, very important. You're going to have to wait till the next lesson because we really just don't want to do too much all at once. That would just throw everything off. So instead, let's look some more inscribed angles and stuff. So, mystery. Is angle 2 here, is this considered an inscribed angle because the vertex is on the circle. And so would this count as an inscribed angle? Take your guess. And the answer is nope. It is not an inscribed angle. Sorry. But it is an angle with its vertex on the circle. It's not considered inscribed because the whole angle is not inside the circle. This is really just a secant and a tangent that have intersected at your point of tangency. Well, that's great and all, but the main thing is that the vertex is here on the edge of the circle. And since it is, it follows the same rules that our inscribed angles did. So this angle is still just half of the arc, and the arc is still twice this angle. And so looking here at angle 2 and angle 1, so angle 1 is still just going to be half its arc. And so I've got angle 1 right here. Whatever that angle measure is, that's going to be half this arc right here from A to B. I'm trying to see if that shows up. Let me get something brighter. There we go. So from A to B, that arc is twice as big as that angle, and this angle is half that arc. Okay? And then the same thing goes true for this other side now. Okay? This angle, angle 2, is going to be half the measure of that arc. And notice this is a major arc, and so I made sure to name it with 3 letters. Okay? So however big this arc is, this angle is half as many degrees. Okay? So inscribed angles or secant tangent angles are all just going to be half of the arc that they intersect. Okay? So now let's look at some special situations about what's going to happen here. So up here, I have this angle right here, angle ABC, and it is intercepting a semicircle. How do I know it's a semicircle? Because through the center. So I'm intercepting half the circle, 180 degrees. Well, if my inscribed angle is always going to be half the arc, this inscribed angle has to be a 90-degree angle. And so let's go ahead and put that on here then. The inscribed angle, here it is, intercepts a semicircle, then I have to have a right angle here. And so if you ever see that you've got this diameter going on, you're like, oh, half a circle, 180 degrees. Then this inscribed angle has to be 90. And notice, there's more than one inscribed angle that can come off there, and they all still work. So you can have this inscribed angle, and guess what? It's still 90 degrees. And this inscribed angle is also 90 degrees because all of them intercept this 180 degree arc. Okay? So good times with that one. Next situation, look for your inscribed angles and your arcs. So here's an inscribed angle, this purple guy right here. Its vertex is on the circle. Well, it's going to intercept this arc. And now this red guy, it's an inscribed angle, and it intercepts that arc right there. Now those two angles together, they form a four-sided closed polygon. Wait, which one is that called? That's called a quadrilateral. And so this is called an inscribed quadrilateral. Also sometimes a cyclic quadrilateral because it's like in a bicycle wheel. Who knew? But anyway, I've got this inscribed quadrilateral made up of these two inscribed angles that end up meeting on the circle. Well, when this happens, these opposite angles end up intercepting the whole circle. See, this purple angle here is intercepting this part of the circle, and this red angle down here is intercepting this part of the circle. And I really wish you could see it better, but yeah. Angle here gets this much of the circle. Angle here gets this much. Well, together, that's the whole thing. Well, inscribed angles are half the arc. So if together these two angles, or sorry, these two arcs add up to the full circle. So 2 arcs equals full circle, which is 360 degrees, then the angles should be half of 360 degrees. So the angles will equal 1/2 of 360 degrees. And half of 360 degrees is 180 degrees. So together, these two angles make 180 degrees. Record scratch. Hold on. What's that mean? 180 degrees, when two things add to 180 degrees, that's right, my friend. You've got yourself some supplementary angles. Up. Got a little excited trying to show you too much all at once. So these opposite angles are going to be supplementary. They're going to add to 180. These two will add to 180, and these two will add to 180. So previously, we only had that happening in parallelograms and in isosceles trapezoids. But now they're going to happen in opposite angles of an inscribed quadrilateral, okay? Because the full arcs are 360, so the angles will be half of that. The angles sum to 180. Good times. And so you're going to see problems on your homework, on your assignment, where I'm going to give you this picture and you're going to have to spot that that's an inscribed quadrilateral, so these opposite angles add to 360. So just be aware that that's coming. I'm going to scooch this down a little. Our last special thing that can happen is if I have two different angles that are inscribed that come into the same angle. So here I've got this purple guy meets up with this green arc, and I've got this red guy meets up with this green arc. Well, if this arc is 40 degrees, then this inscribed angle that intercepts it has to be 20. But so does this angle have to be half of it. And so what we say here is that if two inscribed angles intercept the same arc, they just got to be congruent, because each of them has to be half that angle. And you're thinking, well, duh, Mrs. Serna, it's obvious, but this is the kind of picture, the kind of illustration you're going to look for. Notice something interesting that happens with this, though. I had pointed out this arc over here, and this angle meets it in this angle, but it works in reverse. I could look at this arc over here and say that this angle right there and this angle right here are congruent as well, for the same reason, because this black one intercepts the arc and this purplish red one intercepts it. And so if this guy was 50, then each of these angles would have to be 25, because they're half of that arc. So anyway, team, that's your inscribed angles. Inscribed angles are always half the arc they intercept. Lots of special ways this can show up. Good luck, team. We'll see you next time.